there are some seats available on the front row, so please come forward and take front seats. Simultaneous interpretation is provided. Channel 1 is for Korean. Channel 2 is for English. Please turn off your cell phone or put it on a silent mode. Thank you for your cooperation.
You dazzle us all, from big to small. Warm laughter and white smiles, red presents stacked in piles. Take me away, Christmas Day. Take me away, Christmas Day.
네, 여러분 안녕.
Good morning, ladies and gentlemen. Let us begin the Day 2 program of BIPC 2023. Welcome to Day 2 of BIPC 2023. I am Jong-chan LEE. I have been given the honor of serving as the MC of today's program. My name is Jong-chan LEE. Busan Port Authority has been hosting BIPC since 2013, and this year marks its 11th anniversary. This year's conference is being held under the theme of the overarching theme, Enduring Progress. This conference has featured various topics, including port development and management and state-of-the-art port technology. And this afternoon, we will also have a special KMI session. After the entire program of Day 2, we'll have the survey for BIPC. Now there is an event of a roulette game right next to the reception desk, so please make sure to take part in this event after today's program. Thank you very much for your active participation, and please stay with us till the end of today's program. Then let us begin session 4, the first session of Day 2. In this session titled Port Development and Management, we will have Choi Sang-hee, Vice President for Research at KMI, Dr. Gye-ryeong LEE, Senior Researcher of KMI, and Dr. Soo-young Lee, Senior Researcher of KMI, as well as Haewon Kim, Associate Research Fellow of KMI. Please welcome our speakers with a big hand. I'd like to ask the speakers and the moderator to take their seats. Then we will begin with the first presentation to be delivered by Dr. Gye-ryeong LEE of KMI titled Application of BIM Technology in Ports. Please give our first speaker a big round of applause.
네, 안녕하십니까.
So good morning. I am the first presenter of day 2. My name is Gye-ryeong from KMI. What I am going to present today is the application of BIM technology in ports. First of all, let me touch upon what BIM is. It's a key enabler for smart construction. And therefore, from the very moment of the infrastructure establishment to the scrapping, you can see that the various data has been accumulated and it can be utilized for the various phases of the facilities. In other words, it provides a digital representation of the physical and functional attributes of assets throughout their life cycle. So BIM has been utilized for civil engineering and construction originally, but recently it has been applied to the infrastructure projects, including ports, road, and rails. Here you can see the BIM project proposals over the past 3 years in Korea, and you can see that the number of projects are actually on the rise. And the Korean government, from the year 2020, it has adopted the policy to expand BIM for public projects. And here you can see, according to the public construction BIM mandatory roadmap, you can see that by 2030, Korea will expand the BIM application in 3 phases. And for the port and road, you can see that from 2023, BIM is scheduled to be expanded. And as you can see from the roadmap, among the civil engineering sectors, port is actually lagging behind in terms of the BIM introduction. So most of the drawings are in 2D in port, and also in terms of the life cycle management and information assimilation throughout the life cycle. Again, BIM has a lot to catch up. So BIM is all about building the digitalization based on the information. It enables the collaboration between different stakeholders. It can also mitigate the risk and reduce cost. And also it enables the digital-based telling, and therefore providing a very reliable data. And also it can enable the digital-based asset information management. According to the MOLIT's guideline, it is necessary to develop BIM guideline for each type of construction projects, including port. And the reason is because compared to other construction industries, port industry does have its own uniqueness. As you know, it covers both the marine and land areas, and therefore it has a very diverse facilities and diverse range of spaces. And also it usually have a long-term construction process. And also, despite the long useful life, it is also exposed directly to various natural disasters. And now let's take a look at some case studies of overseas countries. So the BIM has been actively utilized. For example, like the Port of Rotterdam, they have the BIM-based infrastructure for effective asset management. For the Koi Wars and also the Bolas, they have pursued the BIM project. And also for maintenance and repair, they also established the BIM infrastructure and use them for asset management. This is the case of the Port of Barcelona, and you can see that the BIM has been actively utilized. So at Protestado in 2007, with the help of the operators from the Port of Barcelona or the Bilbao, they have come up with the guideline for BIM. And for the Port of Barcelona, they also establish the 3D-based BIM digital twin in order to manage aquifer and also collect the atmospheric data. And as for the port of Antwerp, again, BIM has been utilized for the quay reconstruction. And so they have applied the BIM from the phases of the construction, plan and design, build phases. And their ultimate goal is to produce the digital twin of the assets based on sensors and autonomous drones. And Korea, BIM has been mostly utilized for the design and construction phases. And so, for example, like the Pohang Yongbyon Bay breakwater, Jeju naval-based projects, as well as the Busan Port International Passenger Terminals, in these projects, BIM have been utilized. But in Korea, when it comes to the maintenance and repair, you can see that the BIM adoption is very sluggish and very slow. And also the information has not been effectively connected to use BIM at this phase. BIM is an enabling technology to enable smart ports. By applying BIM, we can establish 3D-based information system, and we can put a lot of dynamic data in order to produce the digital twin. And based on that, we can also connect that with the various intermodal transportation systems in order to realize the vision of smart ports. Now, what are the things that we have to consider before applying BIM in port projects? Number one is the integrated information management system. It must be established. As for the Korea's port projects, the design phase is, we have a fragmented systems. So for the maintenance, repair, and for the phase and design and construction. So what we need is an integrated information management system that can manage entire data throughout the life cycle of the facilities. Second thing that we need is to establish digital-based collaboration system. Digital collaboration system is the core of the digital transformation for the construction industry. We have to move away from the web part or the email. Rather, we have to create a collaborative environment where everybody can be on the same page and effectively share their insight and information for smooth cooperation. Third, we have to establish the open source-based BIM library. So individuals and also the companies, they have established their own BIM libraries, but we have to move away from this kind of situation. That we have to build open source-based BIM library in order to ensure project efficiency, consistency, and also the quality. Last but not least, we have to also establish a BIM application guideline for port construction projects. In Korea, the relevant ministry has come up with the guideline for 2D drawing, but for the activation of the BIM in port construction project, we have to provide a more detailed guideline for BIM application. And therefore, in order to promote the use of BIM in port construction, I believe that we have to develop a detailed guideline based on 3D modeling. And so this will conclude my presentation. Thank you very much.
네, 고맙습니다.
Thank you, Dr. Lee, for highlighting the importance of BIM for the construction of a smart port. I truly came to see that its importance for the future of Busan Port. Now I'd like to invite Dr. Lee Soo-young of KMI for her presentation titled The Global Port Productivity Trends. Please welcome her with a big hand. Good morning. I am Lee Soo-young of KMI. I am currently working at the Port Research Division. I'm very honored and privileged to be part of Busan International Port Conference. Thank you very much for having me today. Let me first go through the agenda of my presentation. First, I'd like to talk about the purpose and background of the study. Then, I'd like to talk about the methodology that we used to develop the Birth Productivity Index and verified its adequacy that I'd like to touch upon the study results. Then I will conclude with the contributions and limitations of this study. After that, I will open the floor for questions. As you know, ports are a key infrastructure that requires massive capital investment and expenditure and have a significant impact on the national economy. In particular, a longer a ship calls at a terminal, the higher the cost it needs to pay. Therefore, terminal's productivity is an important consideration, not just for shipping companies in selecting ports and terminals, but also for port operators. Then, do we have any index or methodology to evaluate the efficiency of ports and terminals? Probably you might think you have seen lots and lots of such research. As many of you may know, DEA or Manquist index is a representative methodology for measuring relative efficiency of subjects. Many studies have utilized these two methodologies and made comparative evaluations of efficiency between and among different ports. However, both methodologies have their own limitations. There are many practical limitations in collecting data of various input and output factors without omission, which prevents comparing a wide range of subjects at once. I think in practice it is impossible to compare the berth productivity of world's 100 large ports by using the DEA methodology. Recently, however, in order to strengthen their competitiveness, major ports container ports around the world are enhancing their capability and capacity to accommodate mega container ships and introduce a smart port facility and the equipment with significant investment. So it is critical to evaluate the efficiency of ports and terminals in a continuous but immediate manner to identify efficiency improvement factors in a short time. The purpose of this study is to develop an index that can intuitively and empirically measure productivity of container ports and terminals. Then to explain the data and methodology used to develop the berth productivity index. To calculate berth productivity index, we use the IHS markets records of ships entering and leaving port of call. Law data covers about 600 ports and 1,500 terminals. We set minimum requirements for the calculation based on raw data to avoid any distortion in the results, because some terminals and ports might end up with high productivity figures because of their very low cargo throughput. In other words, in order to cover container terminals and ports above a certain size across the world, we selected data meeting the conditions from raw data. And then we produced the berth productivity and ranking for about 400 ports and 1,200 terminals extracted from the selection process I just mentioned. Then let me turn to the data selection to prevent any distortion in the results. In the case of Busan, we acquire 30 to 35% of the data, so the sample size is not an issue. So there is no risk of a distortion of the data. As you can see in this diagram, there are many different factors that affect port competitiveness. Out of this, cargo handling productivity is one of the key indicators for evaluating port service level. So after COVID-19, over 8,000 TEU vessels, the share of those large-scale vessels is going up. And in the case of the United States and China, the data we get, you can see the number of vessels coming in and out of the port. To calculate the berth productivity index of ports and terminal, we developed the cargo handling productivity index with the number of lifts of containers per hour. But although this is not the only indicator which will show the service level, but it's definitely one of the many indicators which can show you the quality of service as well as the level of services offered by ports. And then that's the reason why we developed this berth productivity index, and we are currently monitoring it. Then I'd like to talk about the methodology, how we calculate berth productivity index. So as I mentioned, well, the criteria is the number of lifts of containers per hour. In this study, the berth productivity can be defined as the number of lifts per hour per ship per vessel. First, we can calculate this for each vessel and then calculate the average value we get from total vessels per terminal or port, and then we can figure out the total berth productivity of terminal or port. In the next slide, I'd like to explain how to calculate the berth productivity by taking an example. As you can see in the picture, there are three types of vessels calling at berths. In this illustration, 4 cranes are working on a 9,200 TEU vessel on the far left. This vessel's berth productivity would be 80 lifts per hour. The berth productivity of a vessel over 8,000 TEU, turning to the right, is the average value of the berth productivity of the two vessels. The berth productivity of all vessels calling at this port is the average of the berth productivity of the three vessels. In this table, you can see the outcome of our analysis. First, by region. Southeast Asia and North Asia, the Asian regions are ranking at the top. And the west-east coast of the United States, with some port congestion issues, are at the bottom of the ranking. This is a country-by-country productivity, but this covers the entire fleet, not over 8,000 TEU vessels, but for the entire vessel, Malaysia ranks 11th and Korea ranks 12th. So by country ranking doesn't really matter. I think, well, port level productivity does matter for carriers, but we can do this calculation and feature the ranking at a country level. Then let me turn to port productivity. So it's so small, so you might not be able to actually read this table, but Qingdao, Tianjin, and Yangsan ports, and Yantian port, all Chinese ports are on top of other ports. But this covers not just ultra large or large vessels, but all the vessels regardless of sizes. And in parentheses is the ranking previous year. This is not an absolute, but Kaimap Port moved 3 notches this year. That means that, well, their productivity is improving. And Tanjung Palace, this Southeast Asian port, has shown higher ranking this year. And as for the Port of Singapore, most representative transshipment port is doing better than other ports when it comes to larger scale vessels, but their ranking is not that high. The Port of Long Beach ranks 26. Right before COVID-19, the outbreak of COVID-19, their productivity level was very low. Then they were not among top 30s, but their productivity is getting higher. Then I'd like to feature key country groups to show you their berth productivity. You might wonder where Busan Port is. Well, Busan Port is not among top 30 in terms of berth productivity. So that is why I grouped them according to their regions. As you may have expected, since the outbreak of COVID-19, all the ports' birth productivity have declined, but after COVID, birth productivity has improved, but the level of improvement is not the same. Qingdao Port and Tianjin Port after COVID-19 have clearly higher productivity. As for Port of Busan, in 2017, Busan was among top 10 or top 15, but the recovery has been rather slow for Busan Port berth productivity, and this covers only over 8,000 TEU vessels. East Asian ports are on top of other ports. Qingdao, Yangsan, and the Tianjin ports are doing better than other ports. And Southeast Asian ports have improved their productivity so significantly. Last year's 7th port now ranks 2nd. And the Port of Rotterdam, when it comes to the larger scale vessels, shows a very high productivity, ranking 5th. And Busan Port, as the year of 2023 is not among top 30, even for larger scale vessels over 8,000 TEU. On the left, you can see major Chinese ports, and on the right, you can see major ports, including Busan Port. Since 2018, for all vessels as well as for larger scale vessels, Busan was very efficient and productive, but with COVID-19, its productivity has fallen quite significantly. So far, I've covered a berth productivity index we have developed and we have been monitoring. And as for the contributions as well as the limitations of this study, as you might see from the methodology, it is quite simple and straightforward, but this is empirical and this is an index that you can use for the immediate analysis and comparison of various ports and large number of ports. But it has some limitations. Well, though we conduct this analysis based on 30 to 35% of the vessels coming in and out of ports, and I believe we need some theoretical backing as well. So this is the end of my presentation. Thank you.
감사합니다. 상황과 시대에 따른 분석.
Thank you very much for sharing with us your analysis and the approach. Thank you for presenting a way for Busan Port to go.
들어볼 텐데요. 항만.
Now we'll move on to the next presentation. So we would like to invite the Kim Se-won from KMI. And she'll be talking about strategies to improve port-related business. Please welcome him with a big hand. Good morning. I'm very honored to serve as a presenter for this BIPC. So I'll be talking about the strategies to improve port-related business. My name is Kim Se-won from KMI. We have some foreigners here today, and some of you may not be that familiar with the port-related industries, and we have many experts in shipping industries as well. But I believe that everybody may have a different understanding about the scope of port-related industries. In Korea, we have the Port Transportation Business Act. According to Article 3 of this act, the port transportation business includes stevedoring, inspection, appraisal, and weighing services. And according to Article 2, the relevant business is defined. It includes port services, ship supplies, ship repair, and also the bunkering, fuel supply, and container repair services. And in my presentation, port-related industries refer to the 8 type of businesses, excluding the stevedoring. And for the efficiency of the research, I actually grouped the inspection appraiser and weighing into one service. And I believe that you may be clear what kind of services are provided for these different businesses. But in fact, if you look at the details of the services, it's pretty diverse. That port service industry includes a variety of subcategories, including towing, security, water supply, cleaning, and so on. So port-related industries provide essential services for the loading and unloading at ports, as well as for ship operation. In addition, this industry is significantly connected not only with ports, but also with maritime transport, ship management, shipbuilding, and other upstream and downstream industries. And therefore, in areas like Busan, where port-related industries are concentrated, they could have a very significant impact on the local economy. Here you can see the internal and external environmental changes surrounding port-relevant industries. Let's first take a look at cargo handling volume in Korea at ports. It has been continuously increasing and is expected to continue to rise in the future. However, the growth rate is gradually slowing down. And additionally, the trend toward large ships, ultra-large ships, is accelerating. As for Korea's ports, if you look at the average tonnage of arrival ships per berth, it's actually increasing, but the number of berths or the number of arrival ships are decreasing. So this slowdown in cargo volume growth and also decrease in the number of arrival ships is directly connected to the sluggish demand for port-related industries. And also, considering this trend of increasing demand, it is necessary to transition the service of port-related industries toward a more high value-added services. Digitalization and environment friendliness, this is a major trend that need to be closely monitored, especially when it comes to the port industry. It is a very labor-intensive business structure, and therefore with the digitalization and smartization, it will also impact the labor structure. And also the carbon neutrality and the environment friendliness, I believe this will also provide new opportunities and challenges to port-related industries, especially with the greening of ports and changes in the alternative fuels. And this statistics, it has its own limitation, but let's just take a look at the current status of the port-related industries in Korea with these numbers. So according to the Port Transportation Business Act, the number of businesses in port-related industries in Korea is counted. And since the start of the tallying, the number of businesses has been constantly increased. Particularly after 1997, when the registration system for port-related businesses was changed to a reporting system. So from the registration to the reporting system, this increase has been even more rapid. However, if you look at the size of individual companies in port-related industry, they're actually very small. 99% of these companies are classified as small and medium-sized enterprises. And also businesses with fewer than 30 employees are actually dominating the market. And for some sub-industries, they are predominantly composed of companies with fewer than 10 employees. In other words, South Korea's port transportation industry is experiencing an increase in the number of businesses in the midst of limited demand. And therefore, it can be said that it's a structure where small businesses are engaged in excessive competition. And also here you can see the analysis of the business performance of companies in port-related industries registered at the 5 major ports in Korea. And the result, the analysis, so here it shows the results in sales growth rate, profitability, stability, and so on. And you can see that all the business management indices are actually showing the signs of worsening. So with these SME-dominated business structures, we cannot effectively deal with the external challenges, and also there is a limitation in providing high-quality services. And therefore, to measure the service satisfaction of the domestic port-related industries in Korea, we conducted a survey on ship management companies, shipping companies, and maritime agencies. And this survey was based on the ServCore model to measure the effectiveness, reliability, responsiveness, and satisfaction. So effectiveness means the timeliness and accuracy, as well as consistency, and also the reliability means how to provide flexible services. And for responsiveness, it's more about the safety and accident handling. Or rather, it's about assurance. And here you see. So this is the result of the satisfaction survey. And the higher the gap, the lower the satisfaction. And you see that the port service and also bunker fuel supply, you can see that the satisfaction level is relatively lower than other sectors. And for reliability and assurance, again, you can see that the overall responses are lower than in other sectors. We also compare the satisfaction levels between Korea and advanced foreign ports, and we try to measure the gap between Korean ports and foreign ports. And you can see that for the ship repair and container repair, there is not much difference in terms of satisfaction between domestic and overseas ports. However, when it comes to the port services, ship supply, and bunkering fuel supply, and inspection, appraisal, and weighing services, Korea actually has a long way to go to catch up with other foreign advanced ports. And we also found several problems that we have to handle. So by addressing these issues, we believe we can improve service quality. For example, when it comes to the ship supply, we have a weak competitive advantage, and also most of the companies are lack of international certification. And therefore, by addressing this problem, we can provide a more reliable and accurate services. And by doing so, we can improve the reliability of our services. And if you look at the Rotterdam port and also the Singapore ports, they are actually ranked pretty high. And so we looked at how they pursue the advancement strategies. And we found that as for the port service industry, you see that the bollard and smart mooring facilities, as you can see from this picture, this is the mooring smart bollard of the Port of Rotterdam and also Japan's smart mooring system. So these kind of advanced systems have been introduced in these top foreign ports in order to assure the safety of workers. And also when it comes to the Singapore, for the towing, they also applied the drone transportation. And also the ShipServe or other online platforms in the UK have been very active. And as for the bunkering fuel supply industry, Singapore has already mandated the installation of MFM or mass flow meters in order to provide reliable services to customers. And also Singapore has pursued digital bunkering. And as in the case of ship repair industry, in fact, Korea has a significant shortage of repair docks which can accommodate ultra-large ships. So the Busan Gamcheon port, this is the only port which can accommodate over 30 million ships, whereas the Singapore possesses the numerous large docks capable of handling various types and shapes of ships, attracting many ship repair demand. And as for the container repair industry in Korea, there are many repair sites on ground, and it increased the lease fees, and also it also creates a lot of congestion inside the container yard, which can lead to the safety issues and also the inefficiency. However, overseas there is a trend of increasingly moving container repair service sites outside the terminals. So we have referenced these overseas examples in order to identify how we can effectively adapt to the environmental changes and improve the service quality and business environment for port-related industries. So I think now is the time for us to devise an effective advancement strategy. And recently, the Ministry of Ocean and Fishery, they became aware of the importance of regulatory upgrade, and they are working on that. For example, the Port Transportation Business Act has been recently revised, and it's going to be implemented at the end of this year. And the new revised law establishes the articles that allow the national and local government support for port-related industries. So it is expected that this will expand the government support for port-relevant businesses in the future. So with the SME-dominated business structure, we cannot effectively handle the external challenges, and therefore, I believe government support plays a key role. And we have also identified advancement strategies for different categories of port-related industries, and we have also proposed several initiatives for such improvement. And my presentation only shows this slide, but this research was finished in October this year, and now it's in the process of the editing. And next year, I believe that the relevant paper will be published. And so once it is published on the KMI website next year, you will be able to access more detailed information about our research project. And with that, thank you very much. And so thank you very much. So we have heard the presentations for session 1. Now we are going to move on to the question and discussion session. So I'd like to turn over the microphone to the moderator. Yes, very nice to see you. As introduced, I am Choi from KMI. First and foremost, I would like to thank you all for taking part in this KMI special session. I appreciate your support and interest. So we have covered 3 topics in this session. The first is about the BIM technology in relation with the Industry 4.0. And the second presentation was about the port services. So how we improve the productivity in port operation. And then the third presenter talked about the advancement strategies for the port-related businesses. So for each presenter, I am going to have some discussions with them. So I will ask some questions to the presenters and have some discussion. And after that, I will open the floor for a Q&A session. So listening to the 3 presentations, I have some questions, so let me address that. First of all, with regards to the first presentation on BIM application, I have several questions to Dr. Lee, the presenter. BIM has already been pretty active in construction and transportation industry, but port industry, we are still at toddler phase for BIM application. And I understand that it has not actually been realized and applied in port industry yet. And I understand that the BIM in port industry is categorized into 4 phases. Number 1, design, and second, construction, and phase 3. I think this is something that was not covered by the presentation. So operation, and I think operation should be included. And the 4th phase is the maintenance and repair. So these are the 4 pages where the BIM can be applicable for port businesses. And in your presentation file, you examined the status of Korea. We just completed the technology development, and 2D electronic design guideline has been devised. But as for the technology development and, let's say, the actual application or the commercialization, where do you think Korea stands? So together with the Ministry of Oceans and the Busan Port Authority, we did the BIM platform establishment project as a pilot project. And since the port is an essential security service, and therefore it could not be a full-phase BIM platform. Rather, we had to establish a separate platform only for port management based on BIM. And I understand that that platform is under operation at PPA. However, it's not connected with information system in the operation or the maintenance and repair system. And as for the actual application, I understand that it's not an open system where everybody can have access. So what you describe is that the BIM can be applicable only for the construction and design phase, right? Yes, so we did the pilot project, and we established the standard for the port BIM, but that has not been legalized yet. So we don't have the legislative framework to support that. Then as you can see from the cases of the Port of Antwerp or the Port of Rotterdam, how wide do you think is the gap between Korean ports and these advanced ports? As for the Port of Rotterdam or the Port of Barcelona in Spain that I cited as examples, they focus more on the maintenance and repair side for the application of BIM. So BIM can play an important role in design and construction, but I believe that the real value of BIM could be realized in the operation and maintenance repair sector. But in Korea, somehow the BIM is not actively promoted in maintenance repair, and this indicates that there is a wide gap with the advanced ports. But only with the BIM in maintenance repair, we can actually move on to the actual digital twin, so we have to make a quick progress. So BIM has been utilized for the civil engineering, for substructure management. But in order to achieve the vision of smart port based on BIM, in fact, the superstructure management should also be included, not just the substructure. So from the design to construction, operation, and maintenance and repair. And also the terminal operation data should also be included as a part of the BIM data. And all these data have to be linked together for effective analysis. But as for the substructure and the superstructure, in terms of the connectivity between the two, between superstructure and substructure, can you also describe the current status for technology development or the operation? Or do you think that do we have an integrated system which can manage both the superstructure and substructure? And if that system is available, then who should be involved in the management of such system? So as for the substructure, the responsible agency is the government organization. And therefore, I think that the government should be involved in laying the foundation for BIM project, and also for the superstructure, such as the stiff dooring facilities and so on. So these are critical facilities for port operation. And these superstructures, they're actually the private assets belonging to the operators. And therefore, PPA or the ministry cannot be directly involved in the management of this superstructure. But in terms of the port productivity and efficiency, they constitute a very important part. And therefore, having an integrated management system for both substructure and superstructure should be established. And basically, I believe that the responsible agency should be the government agency, because they have the ownership for substructure, and for superstructure, it's somehow leads to the private operators, and therefore the key responsibility should lie with the government agencies. Thank you for that answer. So in order to have the smart port based on BIM, I believe that the ownership, so whether it belongs to the government agencies or the private operators, what's important is to enable the data integration and effective management of data between these public and private sectors. In order to have a predictive analytics, I believe the integrated data management is a key, and it's a must. So I think this is something that we have to pursue for the development of BIM. So thank you very much for the answer.
Then I'd like to turn to Dr. Lee, who delivered a presentation as to global port productivity trends. As I listened to the presentation, I was kind of shocked to see that Busan Port is not even among top 30. Then I kind of suspect the accuracy of the data analysis, but at the same time, there must be some aspects we have to consider further. Dr. Lee, the high productivity and high port productivity is the same as high port service quality. And please tell us the relationship between the two, the service quality and high productivity. Well, we at KMI were also surprised to see that Busan Port is not among top 30. So we looked into the data once again, as well as the methodology, to see whether there has been any error. But we have conducted this analysis since 2014, and we look at various ports and berths. So I don't think there is any error in calculation or data. Whether what this represents the level of service offered by ports, among top 30 or outside top 30, berth productivity does not necessarily mean that there is a poor quality of service, but this is one of the indicators to. This is an indicator to see the productivity level, because we look at the handling capacity. So we publish port and terminal productivity level on our website, and this is for monitoring purpose. Now, we have also seen that the trend in productivity level also is aligned with the level of services people actually feel or the quality of services. So this is something that can serve as the basis for measures of improvement. I think this is the approach you can take, although this is not an absolute figure or the final picture, but this is something you can refer to. My idea here is that rather than covering all the vessels regardless of sizes, and then looking at larger scale vessels over 8,000 TEU, I think you can group vessels into different categories like mid-size, large scale, and subscale or small vessels. I put it up out there as a possibility because in the case of a port of Oman, the port itself is very small in scale, and the vessels coming into the port are very small in size. And if they have a quay crane, a very large quay crane, then their efficiency would go up so significantly. That is why I'd like to propose that you have 3 different groups, and as well as covering the ship to quay crane size and the size of the vessels that coming into the port. So with these 3 different conditions, you can put those vessels into 3 different into 3 different groups according to the sizes. Then the Port of Busan's ranking would go up quite significantly because the Port of Busan handles mostly large scale vessels. And what is your take on this kind of idea? I think that's a great idea that deserves further consideration. Well, terminals or ports in the Middle East, they rank on top of other ports. Well, that's one of the limitations we have identified. I told you that there is a minimum requirement of the scale of ports. It doesn't really make sense if a very small-sized port with one larger scale quay crane ranks at the top. If we take your proposal and put all the vessels into 3 different groups according to their sizes, as well as the number of cranes, I think that can be incorporated into the next round of analysis so that we can see the relative productivity level of larger scale ports. Thank you very much for your idea. Thank you.
발표
Now, for the final speaker regarding the port relevant businesses, I'll have a question to Mr. Kim Se-won. So how important port relevant businesses are to port industries? So when we talk about the port relevant businesses, the first thing that comes to our mind is only the terminal operation. But terminal operation by and of itself is not really a large business in terms of revenue, but it has a lot of public function. Because if the port is paralyzed, then this could affect the whole export and import of the entire nation. So for the port industry, how can we classify this industry? So this could include the terminal operation and all the other subcategories of the business. But definition of those subcategories has not really been clear-cut. And also the relevant businesses, because of the lack of clear definition, we cannot really effectively come up with a status on the number of employees for each subcategory. So how mature do you think the classification system for the port business? Or definition? Yes, so if you divide a port businesses into several categories, one of the major statistics is the marine fishery statistics, which is announced by the Ministry of Ocean, but actual survey is conducted by KMI, and they have the major and minor and detailed classification. And if you go to the Korea Status Service website, you can check up down to the detailed specification level. So the port business can be divided into the port service and port management sector. And also we have a national statistics released by PPA. And they also cover the shipping and port businesses. And so this is a bit different from the port and rather the fishing and maritime statistics. So in other words, there are some discordance between the statistics. And also for the port relevant business, what's the percentage of the port relevant business in the overall port industry and how much importance it carries? So based on the ministry's statistics, so there are about 8 kinds of the port relevant businesses. But so in order to calculate the percentage, you have to have a clear number of denominator and denominator. But it's actually very difficult to define the scope of the denominator, and therefore it's hard to talk about the percentage, the exact number of the percentage. And also the port relevant businesses, it has a lot of small subcategories, and therefore the statistics can never be perfect. But for the 5 major ports in Korea, based on the number of businesses registered, we analyzed their performance and management status. And based on that, we extrapolate the numbers to come up with the denominator. And we found that the overall port business is worth to be about 53 trillion won. And we found that this is pretty large as the shipping business. And for the statistics classification, yes, it's not easy, but based on the special classification of the maritime and fisheries businesses, I hope that we can hone and refine the subcategorization system to come up with more accurate statistics. So in your presentation, you said that the digitalization and various other things are important for the advancement of the port-related businesses. But what about this idea that most of these businesses are small, SMEs? So for the stabilization of the business, do you think that the government should provide more support, or digitalization or other technologies are more important to promote their businesses? So when I prepared the research project, the first proposal that I made was the smart or digitalization of the port-relevant businesses. But many people said that it's too early to talk about digitalization for port-relevant businesses. So I actually eventually changed the title to the advancement from smart digitalization. So at the time, my goal was to assess the status of the digitalization in Korea to identify the gap. So when it comes to digitalization, I believe all the subsectors require more digitalization, and for automation, some sectors with the infrastructure have to pursue automation. But as I mentioned in my presentation, because of these structural issues, I think that the single company cannot really pursue this kind of project. And luckily, with the modification of the Port Business Act, now we have a more strong legal ground to support the larger subsidy or support from the government. And so thank you very much for your answer. And now we would like to open the floor for Q&A. So if you have any questions, please raise your hand and identify your name and affiliation.
Good morning. I am from Export. I will be part of the coming session. First of all, congratulations for the session. I think it's a very complete, very advanced and high quality speakers and sessions. My question is for Dr. Lee on the BIM and Dr. Choi as well. So I really agree on integrating data across different platforms, right? I think that there are different efforts done for digitalization and digital twin on the BIM, but also when you think about GIS or TOS systems, so all those are creating digital twins, right? So my question to the both of you is how you see the interoperability between the different platforms, because at the end of the day, we are creating different digital twins and they will need to understand each other. Thank you.
First and foremost, as for the data integration, I wonder what's your definition for the data integration, but when it comes to Korea, we don't have standard for BIM yet, and therefore we still have a long way to go to have the system for integrated management. And for technology and interoperability, I may not be able to answer the question. But as far as I understand, Korea is trying to come up with a standard, and based on that, we try to establish an appropriate system. So that's actually the current status of Korea. So did I answer your question?
질문 있으신가요?
Part of it, yes. I think that, especially Dr. Choi, you mentioned about the integration of superstructure, meaning the maintenance and the operations. So I would like to understand further what are your thoughts on integrating maintenance and integrating operation.
제가 질문을 다 잘 못 들었는데 다시 한번 말씀.
Can you please repeat your question? I'm sorry.
Of course. You mentioned about the importance of going beyond the design of the infrastructure with BIM and integrating maintenance and integrating operations. Can you share your thoughts on that path?
예.
So generally speaking, so the port for civil engineering, so we have a operation system for the superstructure, so for the stevedoring and unloading and everything. And we cannot design the substructure without understanding the superstructure, and therefore we can input the if we use the BIM for the substructure, we have to have an idea for superstructure. Only then we can establish the integrated BIM. So depending on the types of the superstructures and what kind of stevedoring system we use, I believe that this could also affect the design of the substructures, including the casing and also the packaging, as well as the layout structures of the substructures. These design could vary, And therefore, you cannot really separately manage the BIM for superstructure and substructure. So these two must be integrated. And also for the operation, BIM can be utilized for various sectors, and therefore the different operation data have to be integrated in order to be utilized for the repair and maintenance for the substructure in order to gear up ourselves for the future risk. So I hope it could answer your question.
That's pretty clear.
오케이.
네, 이렇게 시간
I think it is time for us to wrap this session up. Thank you very much for your active participation. Please give our speakers and moderator another big round of applause. Thank you very much. Now we will take a 20-minute break. So coffee and tea as well as snack are prepared in the lobby. So please enjoy your break, and we will continue at 11 with the second session of day 2. So we will have 20-minute breaks from now on. Thank you.
Are coming true, that's why I cheer. I've been busy decking the halls. I've been kind to big and small. And now it's time to have a merry holiday.
네, 여러분 이제 오늘의 두 번째
Now we are going to begin session 5. I kindly ask you to take your seats.
네, 여러분 이제 BIPC
So we will now have the session 5 for BIPC. So the Oscar PERNIA from next to port, and the DOMMESTRUP from DP World Korea, and Jong-chan from Hyundai Construction. They will be participating as speakers. So we would like to invite them to the stage. Please welcome them with a big round of applause.
네, 감사합니다.
Thank you very much. This session is titled The State of the Art Port Technology. For the first presentation, I'd like to turn to Mr. Anders Dommerstrup, the CEO of DP World Korea, for his presentation titled New Technology Initiatives in Terminal Operation. Would you please go to the podium for your presentation? Thank you.
네, 여러분 박수 부탁드립니다.
Please give them a big hand.
I think everybody can hear me. Thank you for inviting me. And I think last year when we were here, we were all obviously very upset about the incident we had in Itaewon. And I heard yesterday we had not a fatal incident, but we did actually unfortunately lose the expo to Busan, which obviously is very upsetting as a half Korean now. So I just want to basically say, well, hopefully next year we will have more luck. So I think as a follow-up to the previous panel, I'm going to give a little bit of a local flair of what DP World is already working on here in Busan, which is exactly around how do we get efficiency. How do we start integrating not only data and digital kind of world, but also how do we create these more economy of scale environments where we can introduce safety, where we can start training people to become more efficient in executing the jobs that are related to the port industry. So part of that is because we can see that we are too often waiting for others to take the lead. And I think one of the things that our chairman within DP World is known for, he rarely kind of sits and waits for other people to take the lead. He is happy to jump off and basically head down the mountain and say, let's go and have a go at it. So We've done a number of things where we have likely taken a bit of a lead and had a go at things that we think will not solve all the problems, but will start take us in the right direction. So I think everybody kind of saw that we obviously have a need to find a way to deal with larger ships. That's not a secret anymore, and maybe not they won't get a lot bigger than they are today, but at least the averages of them will remain to go up as we see a cascading through the trades. Based on that, we obviously need to make sure that we can follow up with the efficiency and the productivity that follows. And that both goes towards feeding the import-export cargo as well as at least for Busan, the transshipment. The other part is safety. And I wish to reiterate it, safety is not because of legislation in Korea has gone up. It is an imperative in our business that safety is always considered and at the forefront of every action we take. It's a must. The other thing we have, which I think was also mentioned in the previous panel, was the fact that we have a fragmentation of industries or companies that are servicing the industry. And what that often leads to is that you'll get because that happens along the entire supply chain. You got an increase in warehousing, business, trucking, everything, and that means there's a drain of skills from various industries as they move into others, because COVID was basically a good case in point where we saw that people didn't want to necessarily work the kind of hours you normally work in a port 24/7. So you get a skill drain. How do you deal with these labor shortages? And how do you deal with the lack of skills or the reduction in skills that are suddenly available to the whole production plant? And that's something we have to deal with. And obviously the only way to deal with that is what has been addressed at EVI. It's innovation, automation, and optimization. But you have to get started. We have to make sure they don't stay with just words and presentations, but actually starts taking shape. So some of the things that we're doing is we're looking at building out what we call box bay. It's a fairly new, it's not a new concept. If you take warehousing, they've had auto racking for many, many years. This is really just upscaling. And I think in the later presentation, I'm sure upscaling of equipment sizes is simply where we're taking technology that's already proven, but upscale it to actually deal with a new environment and new, basically, sizes of equipment that needs to be handled. So obviously here, we have something that is very kind of different from the traditional. But what it also allows us to do is suddenly introduce solar power. This can actually basically produces 3 times the energy that it itself consumes. So you're starting to actually build in platforms that normally are not available in terminals because it needs to be used to drive around on. Here we've integrated into a structure. We don't call it a building, we call it a structure, where you can actually start adding components that are actually complementary to the outcomes that you want to achieve, which is zero harm, zero emissions, and a lot zeros behind a good productivity number. So high efficiency. So again, it's a very simple kind of concept. It's a little bit like Lego. What we're working on is how we can put it together so we can deal with different kinds of ways we can operate in ports, whether you run with trucks, whether you run with automated trucks or straddles or whatever you do. All of these things are now basically being incorporated so it's repeatable and it's standardized in the way that it's dealt with, and also making it easier to implement. We built something in the beginning that was very kind of intense and looks very kind of heavy on the infrastructure, and that's something that we're also kind of making it lighter so we can actually do it in a faster time and also do it at a lower cost, because whenever you build something like that, any time you build something new, it costs money. And I think something that our industries are suffering from is the fact that it costs money to do things differently. And how do we invest and how do we take it back? One of the advantages with our chairman is he doesn't care. He says if he's got a vision, let's go and get it, and then we'll sort it as we go. And I think we're at a point where we're looking very heavily, or we actually announced we want to do it here in Busan, to basically get it operationalized, get in and basically test it in a high productivity environment like Busan. I can go through all this, but I think you've all seen it many times, exactly what it does. It's really an automated yard, completely automated, and the advantage is that you make things very predictable because you do not have all the yard shuffles that you would normally have. The other part is you have no people. There's no interface to people. They're all gone. And you have a very high safety because you won't have toppling containers, even though you're having a 60-meter tall building. You don't have all the need for lights or people running around. So you're really starting to meet all the necessary kind of components which you want to deliver against. And lastly, the environment. It's very low maintenance, it's very low consumption, and it has the ability to actually use the surfaces for solar, not least the roof. The other thing we have already done, and I think it was presented and very vocally at the previous panel, is our equipment repair. We need to get scale. We have a lot of individual small contractors doing stuff in a very manual, very unsafe because of the actual environment, where we have to deal with it and make it more efficient, make it more safe, and obviously remove all the, you could say, diesel guzzling components of it. How do we electrify things? So again, one of the things that we went for is we started replicating parts of the way that we are doing the normal operations, meaning we will actually make a very dedicated area. It's high cost, but again, it's again a commitment to meet the goals of zero harm and zero emissions, which is, we're a little bit away, we still need to work on that, but we have significantly lower emissions by using electrified equipment. And allowing, you could say, this to be high productivity because you actually get no delays between the feeding of containers to the people that are doing the repair. So something we've invested in, it's a lot of money, but it's a platform. We said we need to do this because this would be our biggest risk area and the most polluting area that we have in the terminals. And it's a business requirement. We need to repair containers in order to feed the export of Korea. The third part here is something that's now becoming more and more accessible, and it's back to the digital. A lot of the tools that you previously needed, engineers and consultants and a lot of work on, are now available online. And something like being able to constantly monitor your yard against the weather prediction, which is available. And we've actually now installed weather prediction tools all the way down to the yard of our, to basically make sure that we constantly can see whether there's a risk to toppling containers. To calculate that is fairly basic, but it's a lot of computation that needs to be done because it's constant, and you have a lot of containers here in Busan port, and therefore we often see that containers are toppling because we're not aware which ones needs to be moved. So the first reaction of a manual work would be to take the top one, which might not be at risk. It might be some completely different place that is not top, that could create the challenge. So we've implemented this, and here it shows, it gives us an overview of the yard constantly that allows us to move containers. And when you say constantly, it's not it's imminent. This is based on projected 48-hour forecast. So that's obviously not 100% precise, but it allows you to focus your effort on things that might be at risk whenever you have weather events. Because normally we only react when the weather is already hitting us, and that's a bit too late. So this is something we've implemented, and it's something we've implemented in a way that we could easily implement it across the entire port with all the other operators, and it's something we're progressing and saying, how do we work with the authorities as well to make sure that these efforts that are taken in order to improve safety, and this will also improve efficiency because you don't have to shuffle containers constantly, nor do you have to actually deal with incidents and accidents for that matter. So something that's very kind of easy to go at. These kind of systems can be expanded, and this is something we're also looking at here, is how do you then get the ships alongside safer, faster, based on the same concept. The ships are getting bigger and bigger, and that then also makes it more difficult to get them alongside, which again lends to, do we have the skills to bring all these new ships that are different constantly alongside and bring them alongside in various conditions, and how do we do that consistently and with prior knowledge to everybody. So again, this is an online tool. So pilots, port authorities, the ships could even access it through, you could say, a portal, and allow them here to basically get a full simulation of their entry to the port. The other thing is mooring. When ships suddenly break free because of bad weather, something we're not paying attention to, but massive impact should they tear down cranes, which could kill people. And it's simple stuff. It's simple, basic stuff that prevents us from having incidents that will take our focus off. Because this is prevention. We are very good at reacting to accidents and subsequently impose all kinds of, you could say, controls on people in order to deal with maybe a very unique incident. This will allow us to get it right every time and have full transparency to all the users, so we don't have the argument around who was right, who was wrong. Often it's not, it's simply to have a consistent approach, and this is based on normal, very traditional science that are now just made available through the web. Normally it won't be. And this is now we're able with the new tools that we have, and I'm sure Oscar is going to talk to how big data can suddenly be used in the everyday. This is one of them. We can actually access something we normally take as a very difficult task and make it very simple and accessible to our daily works. This is kind of how we can codify skills that has been lost over time. So something we're investing in, it can be made available to everybody. That's really it. So I think I made it up right in time, so Oscar is happy, so I won't be. Thank you very much.
네, 감사합니다.
Thank you for your presentation. Then let's turn to our next speaker. I would like to invite Mr. Jong-chan LEE, Senior Vice President of Hyundai Engineering Construction, for his presentation titled Port Construction Machinery Enlargement and Application Cases. Please welcome him with a big hand. Good morning. I am Jong-chan from Hyundai Engineering Construction. Very nice to meet you all.
Was preparing English version for this presentation, but Vice today, almost the audience and the attendance is Korea, so now I immediately change to the Korea version in English. So anyway, I believe to translator maybe better than my presentation as well. Thank you. Anyway,
today I'd like to talk about port construction machinery enlargement and application cases. This is the agenda of my presentation. First, I'd like to talk about the vessel enlargement and effect of port construction. which will be followed by machinery enlargement for port construction. Then I will conclude with the case studies for port construction. First, vessel enlargement and effect on port construction. As you can see here on the slide, the size of container vessels has been steadily increasing as economies of scale are pursued. Currently, 24,000 TEU vessels have begun services, have been in service already, and if this trend continues, we will see 30,000 TEU vessels in the near future, with the bigger vessels, full load draft and width increase as well. So existing port facilities have some limitations when it comes to accommodating those vessels. That is why growing the size of the port facility is also essential. So my focus is, or the main item here is the casing, because I am from the engineering construction company. As port facilities become larger, so do the structures that make up the facility. This chart shows the trend in the size of casings, one of the port structures since 2000. The casings in 2000, casings weigh around 2,000 tons in the early 2000s and have gradually become larger, and casings now weigh about 13,500 tons. It can be inferred that as port facilities become larger, it is natural for the elements that make up those facilities, as well as the equipment to construct them, to become larger. Now I'd like to talk about machinery enlargement for port construction. There are four main areas in port construction: dredging, quay work, floating structure or floats, and offshore structure. As you can see, as for dredging, grab dredges are used to dredge small canals and marinas and are applied when the dredging volume is not large, and this has been in use over 100 years. And currently, the size of the grab is as large as 200 cubic meters, and Japan runs those three large-scale grab equipment. Then let me turn to bucket dredges. They are capable of dredging large volumes, but are applicable to relatively soft ground, such as clay or sand in shallow locations. They are not getting bigger, but only 1 cubic meter size pocket is in wide use. Then let's talk about dredging. Cutter suction dredger and the trailing suction hopper dredger are widely used. With the expansion of port facilities, there is a need for highly efficient equipment that can dredge large volumes, and the cutter suction dredger and trailing suction hopper dredger were introduced. The cutter suction dredger breaks up hard ground with a cutter and then suctions it for further processing. In Korea, about 20,000 horsepower dredger was produced, but mostly for soft ground. But due to long distance of transportation, well, they are not really strong in Korea. But in Europe and the Middle East, cutter suction dredger is quite actively used for hard ground, like Suez Canal. But it entails some environmental issues which need to be addressed. Turning to the trailing suction hopper dredger, it sucks up large amounts of soil through a vacuum cleaner-like intake. As for this, The 5,000 cubic meter trailing suction hopper dredger was used, but the size has gotten way bigger now. It's up to 50,000 cubic meters. Trailing suction hopper dredger is highly efficient because it can be used in conjunction with landfills such as general dumping, rainbowing, and the use of the drainage pipes. It can also be applied to water depths of more than 100 meters when equipped with a deeper dredging suction loading arm. Then let me turn to the equipment applied to the construction of the quay wall. The quay wall can be broadly categorized into caisson, sheet pile, and pier. Well, the categorization is slightly different from that of engineering. For small cascade walls, a floating crane with a lifting hose of 3,000 tons was used, but as the size of the cascade has increased in recent years, a floating dock has become a common practice. First, the caisson is built in a factory-type shop on land, and the caisson is shipped on a floating dock. The cascade and the floating dock are transported together, and the cascade is stacked at an appropriate location. What you see on this slide is a floating dock called a royal dock, which can load 4 caissons at the same time. Floating docks as large as this one are often applied when conditions do not allow for a land-based fabrication yard or when a highly efficient transfer and storage operation is required. This was used quite frequently in Japan. But in Korea, at a floating crane level, using a unlanded sliding system, we do the loading. That's the system in use in Korea. As you can see, the inner wall of the sheet pile, which is built on soft ground, is built using a biver hammer. Vibrations are applied from the top of the sheet pile to install or remove piles. Durability was at issue. That's why this is not really actively used these days. Pile jetty type retaining walls on relatively firm ground are installed using a hydraulic hammer. It is a method of building a pile by heating it with hydraulic pressure. And let me turn to floating structure. Floating structures have been commonly applied to marina facilities where small vessels are, but with the development of technology, large float that can accommodate larger vessels and utilize small space inside are being developed in Monaco. For example, a 350-meter float has been applied as a berthing facility in breakwater. Here you can see a floating berth and floating city currently being planned in Saudi Arabia. We expect to see more plans utilizing floating structures but they have the water depth of 500 to 600 meters. So the existing quay wall construction method would not work for such a deep water. That is why hundreds of structures will be connected to build this water floating city. Currently, there is a growing demand for green energy, and the development of offshore wind farms is progressing. To install offshore wind farm structures, jack-up barges or offshore wind installation vessels are used. Initially, jack-up barges were used to install offshore wind power. But as the capacity of turbines increased, the need for dedicated vessels grew. Currently, Hyundai Engineering Construction built and is operating a dedicated vessel capable of installing 10 megawatt turbines in the near future. We believe that offshore wind power will require a larger capacity, and we are preparing to build a 30,000 ton dedicated vessel to install 20 megawatt turbines. Here, you see a 14,000 ton offshore wind vessel owned by Hyundai Engineering Construction that is currently used to build the Hannim offshore wind farm in Jeju, Korea. As the demand for offshore wind power grows, it is also being explored and considered to build offshore wind farms in deeper water area. For this purpose, turbines are connected to floating structures and floated offshore to form wind farms, especially in Europe. Taking one step further, equipment and technologies with specialized purposes are being developed. The equipment shown here is a robot for underwater construction work that is currently being developed, and it has gone through demonstration stage. It has been field tested, and more construction robots will be developed and deployed as offshore and underwater work increases. As offshore structures become larger, submersible barges for heavy lifting are also in operation. This equipment enables the transportation of harbor structures such as caissons and offshore platforms. When a tunnel is required in shallow water, submerged tunnels are also applied. This involves building a floating body in the form of a concrete box and dropping it to the seabed to form a tunnel through cementation and drainage. Currently, the longest submerged tunnel is the Fehmarnbelt Tunnel between Denmark and Germany. It will consist of 217-meter long concrete elements that will be sunk into the sea to form an 18-kilometer tunnel. Construction began in 2020 and a target completion in 2029. Let me turn to case studies for port construction. Let's take a look at the construction of the Singapore Finger 1 project and Singapore 2S area. First, we set up the workshop and pour the floor slab. The floor slab is moved and the caisson walls are built using the slip form method. After that is loaded onto the floating dock. The caisson wall building takes 3 days. Then we drag the caisson and floating dock onto the tugboat to move it to deeper water, and then sink the floating dock to launch the caisson. The loaded caisson is transferred to the tugboat, and the compartments are filled with water for final placement. So this method reduces the margin of error so significantly as compared to existing methodologies. This is a very special floating structure, floating breakwater installed at the port of Damen, Monaco. It is a single structure, 352 meters long, made of reinforced concrete and post-tensioned, with a total weight of 163,000 tons. It serves as a breakwater against waves, as well as a quay for ships to berth. It is also multi-purpose, with an internal parking lot and a terminal on top. Then I'd like to touch upon the construction method. A dry dock is built on land to form a workshop and build a hull. The dry dock is filled to float the hull. Then We excavate and dredge to open the coffer dam and sink the hull. The vessel is transported 1,500 kilometers for 12 days to the installation site. The hull is lifted onto the position by a crane and the connections are finalized. Then I'd like to brief you on the Kuwait New Oil Pier project. A pile-supported structure located in the Fahil region of Kuwait. The client is KNPC and the contract payment is 100 million dinars. The construction period will be 3 years from September 2000. This is a project to build a platform where oil vessels berth by placing steel pipe piles in the sea and a trestle through which pipelines pass. Setting up a jack-up barge and crane to build the steel pipe piles in the sea are done. Then the piles are positioned and the steel pipe is driven with a hammer. The RCD rig drills and fills the bottom of the pile to complete the pile construction. And then the concrete is poured on top of the piles using a batch plant that allows you to mix concrete at sea. So I covered the various types of equipment as well as the construction methods currently in use in the construction and engineering sector. This is the end of my presentation. I look forward to your question. Thank you.
네, 감사합니다.
Thank you very much. Thank you for such an informative presentation as to the port construction machinery as well as the applications. Now, I'd like to turn to our last speaker in this session, Dr. Oscar PERNIA of Nextport AI. His presentation is titled "The Digital Twin and Artificial Intelligence Transforming Decision-Making at Ports." Please welcome him with a big hand.
Good morning. Well, this is the last presentation on the last session, so I hope that I can match the expectation. Thank you very much, BPA and the organization. It's been a fantastic event. I think I do agree with Mr. Tim Power that this is maybe the best port conference in the world, at least from the ones that I attend. So thank you very much. The topic of my presentation is going to be on digital twin and artificial intelligence and how we put those exponential technologies together for transforming decision-making at ports and at terminal. A little bit of background of our mother company. So we are belonging to Moffat & Nichol. Moffat & Nichol is an engineering firm based in California. Maybe not the biggest one, but maybe the most specialized one in ports. We do from design to implementation to integration to optimization. And we were ranked #1 in US last year. So Moffat & Nichol invests in export as part of the technology and innovation strategy. We are 28 people in Spain that are working together with 27 people in US, and we put together different technology efforts. So about I think the Commissioner Port of Seattle, Sancho, mentioned about smart ports. And I do agree with him that for smart ports, the ports has to collaborate on framing that vision to reality. This is our humble vision. So for us, it's about putting together the components that need to be taken together again for moving from physical infrastructure to digital infrastructure. On that path, it's very important that the information flows and the physical flows are putting together. That means process understanding. Without domain expertise, it's very difficult to convey on smart solutions for ports. And on that, I think it was mentioned in the previous session, data integration is key. Our industry is lacking standardization and is lacking interoperability between platforms. And it's very important that we can make sense of the data in a very simplistic way. So from that point, of course, measuring and analyzing is one step, but our industry is a plan B industry, meaning that we need to be focused on being resilient and being focused on contingency management. And for that, AI machine learning can help a lot on anticipating and predicting What we do with the digital twin is on making the digital twin a component that is making AI easier to consume. And it's also being inclusive with the user. I will explain in a minute with some practical use cases. And then, of course, the smart port is coming from the digital transportation of ports. It's talking about the ports being more transparent, more efficient, of course, more flexible, and more sustainable in terms of the environmental impact, and very important, much better connected to the supply chains. Then, in terms of the portfolio of solutions that we are building, Moffat Nichols has a strong tradition on simulation and emulation. So simulation is everything that the company does from 2008, when flexing was acquired for ports and terminals. And then we use that for design, capacity calculation, or everything going from design to implementation, also for expansions. On emulation, we get to connect the systems. I will explain what we do with PSA in Singapore. And then with Nextport, what we are doing is enabling the big data opportunity. So making sure that the different data sources are combined and are useful, making sure that we can interoperate with the different systems. So we are trying to be system agnostic. That means the different platforms that the ports and the terminal has, which are the two market segments that we are tackling so far. Takeaway here, without data in quantity and quality, AI will have a minor impact. And this is important for an industry that has many different platforms and many different systems. And we have a lot of data, but you know, we are not able to squeeze so far the value of data. And then on the digital twin front, what we are trying to do with digital twin is to create also the core foundation for AI, because processes, system, and data has to be put in together. And then also very important for AI, which is complex. We try to make it practical. We try to make it useful for the user. And the user has to be having empathy with AI, meaning that we cannot throw AI to the user and expect that from one day to another, the user will become more intelligent with AI. Then this part of the presentation will be very practical. I will be explaining what we do for ports, and I will be explaining what we do for terminals, and I will be going through some cases of study. Our company is in a very early stage, so we are developing our product as we go, but we have some relevant experiences already with some potential customers, because a product like the one that we are developing cannot be developed in a lab and then expect that it's working perfectly from the first day. So for the ports, the two paradigms that we are trying to put together, one is just-in-time operations, not only for the vessels, but also in the land side, and synchromodality, meaning the connection between the different transportation modes, improving utilization, minimizing also waiting time. One area is port call optimization. I will be explaining for ferry operations in a minute what we do there. We also work for containers, we also work for breakbulk, and we also work for any kind of traffic. And then there are many solutions focusing on predicting the ETA, and that's very important. But what is happening in the port, meaning the coordination around the pilotage, the towage, it was mentioned by Anders, right? The mooring as well, is where the waiting time is created. Sometimes the ETA is predicted, but then the vessel has to wait, and that has enormous implications on making the navigation of the vessel sustainable. And then we connect the land side, because there are not that many solutions that connect the land side. So water side and land side together, and being able again to anticipate. One of the projects that we ran last summer actually was from the minimum viable product that we have already, our platform. Between Tangier and Algeciras, there is a extreme intense traffic during the summer. So the people is coming on vacations, beginning of July or end of June, and then is getting back before the school starts to Europe, end of August. So 3.3 million passengers across the strait, 750K vehicles across the strait. This is happening in 2 months, but actually the peaks are concentrated in 2 weekends in the way to Morocco and in 2 weekends in the way back to Europe, right? It's a massive operation, very different to the normal patterns across the year. What we did with Port of Algeciras and Port of Tangier is to put together different digital tools. But the most important part was to combine different data that is fragmented today, that also was mentioned before. So we have vessel schedule, fleet plans, we have the forecast for the traffic, we have the parking area occupation, we had the ticket sales forecast as well. So all those data pieces were disconnected. We put everything together in the platform. And then from that data, what we do is trying to create a different decision-making tool for the user. The digital twin is not the 3D. The digital twin is the data and what you can do with it. So in this case, operational visual management, meaning being able to take decisions with context, but also the berthing becoming not anymore a dashboard, but becoming something that is predictable and is reliable. And then the connection of this with the machine learning is that the machine learning is having 3 years of data where you can predict when you are going to have a conflict in the berth. And then the system recommends what to do for those conflicts. And when you have a solution for the water side, you can simulate what will happen in the land side for the coming 24 hours, which is the role of the simulation that I have here on top. Then the value for these customers, in this case the Port Authority, is about, of course, having a data-driven decision-making, but much better control and an orientation to continuous improvement. When we are talking about a control center, but also different stakeholders, like, for example, security authorities that are very important in this process, that need to be synchronized, let's say. Of course, the Port Authority and the liners are focusing on efficiency for example, the vessel rotation, but also the utilization of those ferry vessels and the environmental aspect of the operation. You can see here in the berthing that ISA berthing has many other berthings are in the market, but it has a machine learning prediction that makes the berthing reliable, the conflict detection and the visualization of that conflict, and very important, when you have the conflict and the solution, you can send the solution to the simulator so you can evaluate the land side. Moving on with R&D. So for the port call optimization, we need different components. We have the berthing component, we have the pilotage component, we have the towage component, we have also the bunkering process, which is very, very, very important. And then on the bunkering process, what we did is to get funding from European Union. They are trying to promote the adoption of AI across different sectors. Apologies, I'm a bit sick, so I need some water. So we got the funding from EU, and we developed the algorithms to be able to basically make the bunkering process more visual, but also more predictable. In Algeciras, but also in Huelva, where we work, the practice is first come, first serve, of course, but this is because the people cannot look ahead. So what we did is to use the framework that is available to generate 2 predictions. One, the duration of the bunkering process, and the second is the vessel waiting time, in combination with the other services that has to happen for the vessel in and out. Okay, and all that is part of the AI plan for Europe, which is a knowledge generation and collaboration initiative, and the results are public. What we got with this, we got the bunkering component that is very important for us. So we productize this into software. So this is, of course, for us, we are very happy to promote AI and to help EU to collaborate with universities and companies that are trying to leverage AI for decision making. But again, with this project, we got to much better understand the bunkering process, and we got data from different ports, so we can productize our component for that. A takeaway here, the ports, of course, will leverage AI for much better utilizing the assets and enable sustainable operation, again, meaning the environmental parameters. And the digital twin with AI will be able to learn from the past when you have data, but also to look ahead more precisely for operation, but also for smart infrastructure development. Very quickly, I have 3 minutes for the terminals. So for the terminals, we are using the same platform, the same technology for ports and terminals, but on the terminal is much more on the micro level. So we have more granular data, we have much more data than with the ports. And then the focus, of course, is at the crane level, at the transportation level, at the people level as well. So we are trying to combine different data sources. And the other thing that we do for terminals, as I'm going to explain for the PSA case of a study, is to help them with system integration. So this is a project we are running with CMA-CGM. CMA-CGM terminals hired us for implementing our solution in 3 terminals. We are working so far in Malta, Freeport, we are working in Algeciras, TTI, semi-automated terminal, and we are working in Los Angeles. And the first problem that they have is that for them, it was very difficult to understand the root causes when they have a problem with efficiency. So for example, the terminal tractors becoming very slow productivity when the yard occupancy is becoming 60%, not congested, but just 60%. And the huge impact on not only the productivity, but also the operational cost when you increase the number of terminal tracks that you assign. Then we developed some analytics combining different sources of data. In this slide, in gray, you have the initial situation when we arrived. So different data from the TOS and from the equipment control system, PLC, IoT devices for positioning, for example, maintenance systems, prime route, which is the global pooling for the TOS. And then fragmented information, very difficult to correlate, very difficult to combine. So we create a single source of truth. In this way, every single move is recorded, and every single move has a track record. And from that, you can learn and you can apply advanced analytics. What we do with that core foundation is to create a standard and centralized way that is system agnostic. Meaning we are independent from the TOS, we are independent from the equipment supplier, we are independent from the IoT devices. For that, we are trying to leverage as much as we can a standard, which is a difficult part. But getting value from data is something that can seem like very basic, but the starting point. Then different tools in the digital twin. So again, not 3D, not fancy visualization, but 2D is important for the user. This 2D is very simple and it's not fancy, but it has alarms, which is very important. The user has to be triggered when something is wrong, and that user, he or she, has to be fed with the timely information and accurate information. This is also what we do in this alarm panel. So we have an alarm panel that is a workflow engine, which is basically assigning priorities to the alarms and helping the user to manage that alarm. And finally, the people, of course, taking data analytics as the basis to be performance-driven and to have a continuous improvement mindset. The value for them, well, sorry. So the value in this case for CMA-CGM is on instrumenting the control rooms in a way that can be a standard across terminals, independently of the TOS they have, independently of the equipment suppliers and the technology they are using for IoT. And then the last one, sorry, I am running out of time. I hope it's okay. So system integration. Busan is a very well-known port for automation. So automation is being implemented here from 15 years ago, even more, right? But always automation is as reliable as integration is done in a way that can be sustainable. So for PSA, I think it was mentioned by Mr. Lee, the TUAS project will be maybe the biggest terminal in the world, so 65 million TEUs. Panjang project already have 32 million TEUs, and PSA has their own TOS and their own equipment control system. And they develop the systems, but they need to test the systems. So in this case, complex behavior like the one with the AGV are modeled as part of the emulation. So the emulation is gathering all the software. So the software is running in real from the TOS, but also the equipment. We are able to frame, to model 600 different type of messages. With that, PSA do interface validation, but also the whole system integration. Database models accuracy is very important because with automation, you have many different applications that are managing and modeling data in different ways. And of course, very important, exception handling, especially when you need to train people. If you have the happy day scenario, the training is easy. When you have the rainy day scenario, meaning something wrong is happening, then the people has to be trained and has to be trained before suffering that in production. So the value for PSA in this case is that we are lowering the risk for the automation, for the system integration again, is a development environment that provides safer testing, bug fixing is much quicker and effective, but also in terms of the fine-tuning and the complexity around the system parameters, this is very complex. And we reduce the risk and we train the staff for making this properly. And finally, the continuous optimization practice, which is important to have it from the beginning, not when the terminal is already running. The last slide, the terminals are getting, I think Anders' presentation is a very good example, right? Terminals are going to get to innovate and to be more efficient. They will get value from data, and they will be applying AI, but today, again, it's very difficult, and I tell this from experience. And the automation needs to minimize the risk of integration or the projects that are late. And I was in some of the projects already, so are because of the integration, and of course, because the training of the people, but using digital twin also for training people and optimization is, in our humble opinion, the way forward. Thank you very much.
네, 감사합니다. 항만의 의사결정을 변화시키는 디지털 트윈과
So thank you very much for the presentation on digital twin and AI that change the decision-making process at ports. Now we are going to have the Q&A and discussion sessions. So let me turn over the microphone to the moderator. So Mr. Oscar PERNIA, please start.
I think it was a very diverse session. I think we talk about different aspects, right, of the efficiency in terminals, how the industry is changing. I think that the size of the vessel clearly are bringing challenges for construction, but also for operation. And I think that also it was mentioned that the industry is becoming more and more connected, also from the supply chain perspective. So it's important that we have a less fragmented way of operating, right? And the different stakeholders are collaborating in different ways, and for that we need to connect systems. So my first question is to Anders. So I think that, yeah, the upsizing of ships, right? It was mentioned, emphasizing the importance of enhancing the coordination of piloting and towage to improve the vessel port stay. So, Anders, how you and DPW envision the technology support and which system need to be involved to improve this? Because clearly it's a multi-system approach what you are following, and it's clearly very important that we get to optimize the vessel in and out and everything happening in the middle.
I think one of the approaches is that we are taking is we don't try to find one big solution that can solve everything. Because like everything, a building is made by a lot of bricks and mortar and all that. And I think with technology becoming easier, it's a lot easier to start interfacing these systems where they need to overlap. I think we want to make sure that we get the specialized solutions or systems for specific tasks, and not try to integrate everything into one integrated system that will give you one answer. Because as you say, there's never one answer. We'd rather make sure that we can take the individual tasks along the supply chain and make sure that the data is consistent as it flows through, but make sure that the specialists in the individual kind of components of our business are really providing the tools that they are specialized in, and not, you could say, an average solutions that are more focused on having everything inside one person or one company providing the all-in solutions. So we're looking at that both for how we automate equipment, as well as how we look at data in terms of a toss or berthing of vessels. It could be individual, because they don't need, there's only few data points that needs to be really integrated. Otherwise, they are different functions in itself.
Sorry, thank you, Anders. Yeah, fully agree with the approach. Mr. Lee, I am not an expert on.
네, 그러면 상무님께 좀 질문을 드리고 싶은데요. 항만 건설에 있어서 선박 대형화가 큰 도전 과제가 되고 있는 것 같습니다. 근데 기술 도입 역시도 쉽지 않은 것 같은데 오늘 발표해 주신 내용을 통해서 어떻게 항만 건설 장비가 발전해 나가고 있는지를 볼 수 있었던 것 같습니다. 그런데 선박 크기 대형화에 있어서 어떤 장비 이런 관계에 대해서 얘기를 해주셨는데도 육상 전력이라든지 이런 기술들이 또 도입된다라고 말씀해 주셨고 정박에 대해서도 앤더슨님께서 말씀해 주셨는데 이런 것 역시도 굉장히 중요한 것 같습니다. 그래서 이런 부분에 대해서 조금 더 상세하게 말씀해 주시겠습니까?
Carries more advanced. Anyway, the new projects often require various support accessory systems or safety and efficiency. To increase the safety of a mooring system, especially the quick release hook. His translation is wrong. Anyway, the quick release hook has been applied in the several projects. Quick release hook control mooring system force through the digital equipment and is release the mooring line when there's critical load is the exit. For reducing the damage for civil facility and the ships and prevent his accident due to its breakage, additionally, we used the bushing aid system. Has also been developed and has been applied in several projects, particularly for its Trestle project in this oil ship mooring system as well. The other one, all the vessel now has already installed for its automatic positioning system. For construction site, we also need to very seriously concern about the developed automatic positioning system as well to prevent any accident during the construction period.
감사합니다. Thank you, Mr. Lee. Then I think that Anders mentioned about Box Bay. I don't know if everyone is familiar with Box Bay, but for me, it was kind of revolutionary idea, right, in terms of the existing container handling equipment. Yeah, you mentioned it's just a warehouse, right? But the engineering inside the concept is quite amazing. So it's a very innovative solution. This brings next level of automation, as you emphasize. My question, of course, coming from a top supplier is, how do you see the complexity for optimizing such an integrated handling equipment from logistic point of view, but also specifically for the TOSAs?
Yes. One of the things that we are looking at always when we want to automate something is obviously two parts. One is the outcome towards the customer. That's always important. You always keep that in mind. The other part is a very important component of what we do is also employees. And I think we try also to deal very often with the kind of a myth that automation is to remove or basically make people redundant. Our approach to automation is to augment the skills of people that are doing a certain task. Sometimes that task, it can go from helping a very manual task to be done better, safer, in a better way. Most of the people call it training. That's the simple form of it. And obviously, sometimes the outcome of an automation kind of review or exercise, what is feasible, might end up with that the task gets fully done by a piece of equipment. But the outcome from the beginning is not to try to remove the person. It is to try to optimize the process, optimize the outcome, and then see where the technology and the equipment can take us, and then deal in a very conscientious way and a meaningful way, how can we then retrain, rebuild around a new setting for the employees to, again, maximize the output towards our customers, which is the most important. We produce whatever everybody in the port does. We produce an outcome for our customers. We move trade. That is the key outcome that we always need to look at. So we're not focused on the beginning to, we want to get rid of people. No, we are focused on how do we optimize this process in a safer, in a more environmentally friendly way, and then sometimes that process leads us to different outcomes as to how the end product within the organization looks.
Thank you, Anders. And before giving the hand to the audience for questions, so Mr. Lee, so the cranes are becoming bigger and the equipment is becoming bigger. Anything that from your perspective can be done in a different way when you design a port or a terminal to enhance the construction process afterwards? Any additional remark that you want to make?
At this moment, almost for construction processing, still is the quite conservative system to use by tendering system by the government authority. We must think about only costing the involved is a high percentage to the work. So to adopting the new IT system or AI system to involve for this project, actually we must give this some advanced position or point to the tendering system in the government. Because why? Almost the construction is managing by the government sector. So even also under the private sector, example is the DP World, they concern about the project. Most of all is the construction cost, mainly concerned to is the costing issue. So the client, as an authority or the private section for same as DP World, is the Morosque, any other thing. They have to considering to certain percentage have to be compulsory to involve for IT system or AI or more high technologies involved. And the construction company also, they should be involved with this kind of high technology college. Mean can be support more automatic control system as well. It's not only developed by client side. Maybe it can be very slow than the other industrial part. That is my concern. So, not only for construction company to involve this project, we must combine with shipping company, government sector, even construction sector, even also user sector, the final industrial part must be they integrate to develop together as well. That is my opinion. Thank you.
Thank you, Mr. Lee. And now I don't know we have time to, we have still 5 minutes for the audience to make questions. I didn't have any question for me, so if someone wants to ask, I will be happy to answer. We have a question there.
Thank you so much for your respective presentations. I do have a question for you, Oscar, with regards to the application of digital twins and green corridors. The Port of Seattle, Tacoma, is currently in a feasibility study with the Port of Busan, Ulsan, and Masan on a potential green corridor, and we'd love to get your thoughts on whether or not you think there's value in creating a digital twin between those ports to see the effects of a green corridor.
Thank you for your question, Sam. Well, absolutely. I think that something that we learned in the last 2 years is that initially we were focusing on the waiting times and the utilization. I'm talking about the cell call process. But then the analytics shifted very quickly to measure emissions and to measure the energy parameters. At the beginning, we did very theoretical with the fuel consumption curves and the emission curves that we have from the vessels. So we have some past background on that from our previous experience. But now it's becoming crucial, especially in Europe with the ETS system coming active in January. To your question about the corridors, for me, the corridors are a very interesting concept that will bring a lot of transformation in the way, not only the way we measure and we look at the environmental parameters, but the way we operate. because it's not only about measuring, but I was working for 2 shipping lines. At the beginning, I was not that aware, to be honest, about the importance of environment, but when I was working for MSC, I was. And when we designed terminals, we were always working with the shipping line, as Mr. Lee also mentioned, to make, the whole chain sustainable. So the green corridors are a great opportunity for digital twins and vice versa, because I think that you don't need to be very sophisticated on the digital twin model. What you need is data, and we start having significant amount of data where we can train models, and we can not only measure the impact in environment, but actually we can work on different strategies to improve, right? That will be coming not only from using alternative energy sources, but also on the way the vessels are operated. Again, coming from experience, for me, the missing link on how environment is managed at the shipping line side is on how planning can be aware of how sustainable is going to be my navigation, and also the operation in the port itself, which is today is managed as we go. And that's my perspective. Of course, we might have different perspective here in the room. Thank you for the question again. We have another question here.
네, 앞쪽에 네 마이크 전달해 주시겠습니다.
So the person in the front. 네, 저는 팀파라고 하고.
Interested in what you were saying about Box Bay. What do you think it could do for both productivity and unit costs compared with a conventional automated terminal?
I think it has the opportunity. It has the opportunity to, as you model it, to basically be scaled up and down. It has access to. You can form it in different ways, whether you want to make it a storage environment or whether you want to make it a productivity environment. Those two options are scalable, which is something that when you build on the ground today is very difficult, because everything becomes distance. And every time we talk about distance, productivity normally is going down, or a number of equipments are going up. Here we have the key here is the concept is around you're minimizing distances, you are reducing or eliminating the, I think Erska had a slide around that within normally your move, whether it's from door to door, or whether it's from gate to vessel, you have a lot of periods where you have waiting time. And I know often people say, yeah, I'm busy waiting. That's a foreign concept to me. If you're busy waiting means that you're unproductive. And sometimes with automation versus people also suddenly drift off and ponder. And so we have a lot of components in there that can be reduced because you don't have it. And if you can start to remove all the bottlenecks, all the bullwhip effects of how you move things, you can obviously if you then mix that with AI, then you can start having a much better predictive kind of approach towards how you allocate equipment, how you move things faster. So yes, I can't give you a number, but I can say that there are some components in there that we are still exploring, that we can see that this allows us to do things, but I don't have the answer how exactly it's going to look. But sometimes you see things and you can see that the opportunities are there to actually do things very differently and approach it for multiple purposes, still with the conscience of people making the decisions around what do I need this piece of equipment for. And that's kind of, it's still that's why we're very keen to develop it, because we can see that it has this, because it also needs to be applicable to a wider audience within ports to be able to accept it, and you build it in scale and all that. Right now for us, we're going into production now as to how we can use it, because we've developed enough concept, and it's conducive for all these concepts of how you operate efficiently and reduce the bottlenecks along the, you could say, the interterminal supply chain.
We are running out of time, but last chance for having a question from the audience. I think we have there one question.
네, 안녕하세요. 저 한국게임신문의 최용석 기자라고 합니다.
I'm Choi Yong-seok from the Korea Maritime Industry newspaper.
있는데요.
I have an external question to Mr. Anderson. So you talked about the box bay, and in fact, in Busan Newport in PNC, for the first time in the world, the box bay is going to be adopted, and I want to know about the progress so far.
Thank you. So we are in the design phases right now, and we're working with the governments to to how do we implement it, you could say, locally as part of a new design to the terminals. There are certain processes we need to go through. So we are in discussions on how that, whilst we are also developing the detailed design on how we want to apply it here. So decision, we want box bay here. That has been taken. The investment is has been approved. What is needed is we still have some work to be done. And right now, in my presentation, you saw we are actually we are changing the way that we do our equipment maintenance. So that area is being vacated now because we are actually getting the new facility built. So we will only get started on anything in around the end of 24, because the area in a fully built out terminal, which PNC is, we need to vacate the current repair area and move that into the new. So it's still a couple of years away, and that's why we are in the process right now of but we have multiple, for DP World, we have other projects that are developing around the world, because we're committed. This is something where we see there are opportunity, not only from efficiency, but environmentally. It has multiple, you could say, ways to deal with the problems that we are all discussing within our industry today.
Thank you very much. Well, we have an additional question there. I don't know if we have time for making the question. Okay. The mic there.
네, 끝쪽에 마이크 전달 주시겠습니까?
Busan Port Authority. Mr. Oscar PERNIA, one of the conference organizers, you don't have to worry about time. I already told MC that taking questions is more important than sticking to time. So you can invite more questions.
Thank you.
Yes, it is important.
More questions, please.
Okay. So my question directs toward Mr. Anderson DOMMESTRUP. Well, I'm not sure you listened to the previous session. One of the session speakers talked about lowering port productivity level in Busan Port. And I have my own unproven theory that maybe this lowering productivity in Busan Port has something to do with low stabilizing tariff in Busan.
Sorry, what was the last?
Low stabilizing terminal handling charge, container handling charge. Well, they say that container handling charge, stabilizing fee, has been at the low level and hasn't changed for the last 10 years. It hasn't gone up. It's very low. And terminal operators say they are not making enough profits. Maybe not enough profits to support capital investment, which includes improving its terminal handling equipment. Sometimes you have bigger vessels, you need to make the equipment bigger, and you need to sometimes replace the older key cranes into newer one. So you need money. But in order to invest, in order to make a major capital investment in facility, you need money. You need to make profits. But according to the rumors, terminal operating companies in Busan Port haven't been making enough money to support all that adoption of new technology. So my question is that do you think that maybe this low productivity in Busan Port has something to do with low stabilizing fee?
That's not a soup question, huh? No. It's a very touchy subject, obviously. And I'd like to split it in two components. We live in a competitive world where we have to compete in whatever we do across different operators within New Busan Port, other locations around. So there is a component around tariff that relates to just competitiveness. So again, it's not isolated as to whether the rates are just too low, because that's a matter of competitiveness and everybody kind of deals with it. I do think what is an overlap into the efficiency on the rates is this. I think as a port, sometimes you're too busy on growing and attracting new stuff that you forget to make sure that your processes are clean. I think what was mentioned in the earlier panel, which I did see and hear, obviously more important that I heard it, was that we have we've had a policy towards we want to have a lot of employment, a lot of SMEs involved. I think what we forgot was they need to be fully integrated into a seamless process towards delivering an outcome. As soon as you don't have a seamless outcome, your cost for a port will go up. So if your cost goes up faster than your revenue, you're in trouble. I think we are at that inflection point where we are, one, we probably need to clean processes and how we do things up. And I think there's a lot of, there'll be a lot of navel gazing towards figuring out exactly. We have a lot of ideas and we have a lot of solutions we're working towards. And I think some of it will be port, some of it will be at a company level. And then as part of that, also then look at how does that impact your competitiveness? Because if your productivity goes up and if your efficiency goes up, your competitive situation changes, and that might allow you to basically address an issue about your tariffs. But to say that oh, we're not, the tariffs are too low and therefore our productivity is going down, I think that's a statement I wouldn't subscribe to, because I think it's something that is then somewhat self-inflicted. There's a lot of things we need to deal with, and I think it's this that we have here that we have the courage to start dealing with things that needs to be dealt with and knock it over one at a time. I think other ports are dealing with same issues because we are dealing with labor issues, whether it's shortage, whether it's skill, whether it's people don't want to work, they want to work from home or don't want to work 24/7. We have environment. Do we need to build more facilities because it has an environmental impact, whether it's on nature, sea life, whether it's emissions and all that? There's a lot of complexity in what we do now. It's not as easy as 25 years ago. We just need to deal with it. We have a lot of people that are interested in dealing with it. We just need to make sure that we get good advice and implement in a sustainable way across not only environment, but across everything we do. And I think there's a lot of work to be done, but it's not a simple statement that our tariffs are too low. That's not solving our problem. That's my view.
Thank you, Anders. Do we have more questions?
시간이
Now is the time for us to wrap up. I'm sorry. We are already behind the schedule. And if there is one last burning question, if that is short, then we can address the last final burning question.
I'm with the American Journal of Transportation. My question is for Mr. Lee. The Port of Long Beach, as you may know, is planning on building an offshore wind port. The port is planned for 400 acres. I forget what that is in hectares, but it's a lot. It will be built with the idea of floating out 300-meter floating wind turbines. You showed in your presentation a smaller version of that. the Port of Long Beach is estimating that they may need to produce 500 of these floating wind turbines, and they would have a capacity of somewhere between 15 megawatts and 18 megawatts. My question to you is, how feasible is this, and do we need help from Korea?
Your point is quite important for our the market in Korea for wind farm system. Actually, my company is Hyundai Construction Company is the first pioneer for the wind farm the construction market in the Jeju Island. Now we are also developing together with many of investigators from the other country, even also USA, also turbine the product company as well. As you say, the deep sea area development system. Not only Korean company, Korean engineer and designer, it's over the world. They much concerned how do they develop. At this moment, these floating systems are quite beginning stage in the Europe, especially in the Denmark, and then it's around the North Europe area. They just start and they just. Develop for the R&D part as well. In Korea as well, we also the Eastern Sea. We also considering about the floating system for in the deep sea, because the wind quality more better than the nearby coastline. So I think this kind of system, the physically the adopt for its actual field, we need the time more, maybe at least 10 to 20 years. But because why? All of the huge kind of the equipment is based on the piling system, mean the shallow seabed level. So main market controlled by under now is Dutch and the Belgium company, or the developer is a Denmark company. Actually, they just start the study for floating the wind farm market as well. But unfortunately, recently the weather climate situation, how to do this one, we need to adopt immediately, or still we need to develop more situation like that. So all of the engineer, even same as the coastal engineer like as me, they need must concern to continue to develop, because this system to Korea over Japan, even the nearby the Philippines or Taiwan, they actually need, but still all of registration and the regulation system still needed to develop together as well. So as I mentioned about that, it's a marine job. It's not developed by only one or two the industrial field. We must combine the integrate initially many of the R&D center, the government center, even also construction center, also the user center, mean is a power company. They must combine together to develop it, because the huge money must involve. Also, we need to get the investor from the other meaning fund as well. So also system-wise, we need to develop together as well. Thank you.
네, 감사합니다.
Thank you very much. This concludes the session 5. Well, thank you very much for your active participation for the Q&A session as well as the entire session. Please give a big round of applause to our speakers once again. Thank you. This is the end of the official program of BIPC 2023. In the photo gallery of BIPC website, well, there are many photos uploaded. And if you want to watch the presentations once again, the videos will be uploaded later at the official YouTube channel of Busan Port Authority. Lunch is prepared. Please enjoy. And in the lobby, we have prepared some eateries for lunch. And we will continue with a KMI conference at 2. Thank you once again for your active participation. And with that, we officially conclude BIPC 2023. Then please make sure to look at the photos on the website of BPA, and the presentations will be uploaded on the official YouTube channel of BPA. Thank you for your active participation. Thank you.
This is the